Hi, grade 9. So what we're going to be doing this week is we're going to be starting to put our electricity into a circuit. So we're going to be having current electricity, which means that it's moving around a circuit. It's going through wires. There's a battery. There's a load. There's all of these interesting parts of our circuit. So we're going to start with what is a circuit, of course. So a circuit is a closed pathway where charges can move. To have a circuit, you need to have a power source, a conductor, something that the wires, something like a wire where the current can flow through, a load, an item that converts the electrical energy into something else. So this could be a light bulb, a fan, a motor, a speaker, and then you need a controller. So something that turns the switch on or turns it off. And that is your basic circuit. It has 4 different components, and yes, you need to know all 4. To draw these circuits, you need to have yourself a circuit diagram. Now, circuit diagrams are something you're going to need to be able to draw. There are circuit diagrams in the program that we're using for our virtual lab this week, and I do show you in another video how to click the button so you can see them. But these are the basic components here. You've got your wire, which is just a straight line, a cell or a battery, and how you remember what the cell or battery is that the short line is the negative, because to draw a negative sign takes just a teeny bit of ink. A positive has much more ink and twice as much because it goes down and across. So that's the longer line, is the positive side. Then you've got a lamp or a light bulb. Now these always look really hard to draw, but as long as you've got something that sort of looks like that in a circle, you'll be good. A resistor is a nice zigzaggedy line. A switch is a half open door. An ammeter is an A in a circle, and a voltmeter is a V in a circle. And you will be able to need to be able to show all of these in a circuit. So when you've got them, you've got the cell, which is a battery, which has one or more cells in it. So basically a power source. And then this just explains how to tell which one again. So the short one, negative, long one, positive. Conductor is anything that allows electrons to flow freely through it. It's a straight line. Your switch turns it on and off. When it is open, you don't have any current flowing because it's not a complete circuit. When it is closed, you have the free flow of circuits. Free flowed in your circuit. I think I might have to restart this. I seem to be tongue-tied tonight. And then resistors are any of the different types of loads. So we're going to have you watch this video. I'm not going to do it right now. When you're measuring the current, we're measuring the amount of charge or the amount of electrons that pass through a point on the wire every single second. Its symbol is I, which means in the mathematical formula, yes, there is math in this unit, I represents current. Now, current is measured in amperes, which means that it is a capital A. None of those are a C, which the word current starts with. So for some reason that confuses people, you're going to be just fine with it though, so don't worry. Then you're going to have these tools to measure. You're going to have your galvanometer, which is just a really, really sensitive ammeter. And then you've got an ammeter here. Galvanometer G, ammeter A. Ammeter measures amps, which are part of the current, which is an I. So your current is going to depend on the type of material that it's going through. So whether it's an insulator, a conductor, or something with resistance. So how much so most electrical devices in your house have around a current of 15 amps or less. So how much is a lot of amps? So when you're looking at it, here's some examples here of different ranges of current in your house. Another video for you to watch. While you're watching it, think about what direction does the electron flow? How do we know that it's the electrons that flow? And do devices all have the same amount of current? Why or why not? Our batteries have positive and negative charges, and those are separated around the circuit. So when the circuit is closed, the electrons flow. In this case, they flow this way. You'll notice they come out the negative, go around the circuit, through the load, and then back into the positive. Inside the batteries, you have a chemical reaction. The batteries force the electrons to accumulate at one end, the negative end, and draw it from the other end, creating a positive end. When you're measuring your voltage is the potential difference. So potential difference is the more science correct term than voltage. So it is the energy at one end versus the energy at the other. So with it, you need to be measuring over an object or in between two different points on your circuit. So whenever you have a voltmeter, it tends to go on either side. It's about the amount of pressure or oomph, how much it pushes the electrons. So the more voltage, the more push, the more energy or strength the electrons move. This is measured in volts. So this one makes sense because you've got voltage measured in volts. The letter is V, and you use a voltmeter that's also a V. And then they call it potential difference. So that's a little bit off, but it will help you remember. So here's another video to explain it to you. And then here, as you go up in voltage, you'll notice that the light is getting brighter and brighter and brighter. So as you increase the voltage, you increase the brightness because there's more pressure or more force going on the electrons, allowing them to have more light be produced. So with our circuits, we want to look at them as analogies. So if we look at it as compared to a water system, we do that a lot because water systems flow. The water flows like the electrons flow through the circuit. So here, each water droplet is like one electron. So just like the water source, you have a source like the electricity. Without a change in elevation, the water will not flow. It'll just sit there in a lake. So if you didn't have it coming from a high point to a low point, there'd be no reason for it to move and you would have no flow. It would be called a lake. So you're going to think of this kind of as a waterfall. So as the electrons or water droplets come down, that's happening because you have a height or a potential for it to fall. So here you're going to have your voltage be your height, the current is the water droplets, and then the resistance is if there's barriers in the way. So are there rocks that it needs to go over? What's causing it to change its motion or to move throughout its fall? That's the first one. The second analogy is here, and it's nice and small. So the person at the bottom of the stairs represents an electron, and the stairs are like the battery because it has to provide that potential energy. So as it climbs up the stairs, it's going to gain potential energy. So at the top of the stairs, it has energy. As it goes horizontally across the top, that's like going through your wire because it hasn't changed its potential difference. It has to go through a load like your light bulb, your motor, your fan, your resistor, and that's going to cause the energy to be removed. So as he goes down, in this case the water slide, the potential energy is transformed into a different type of energy. So that energy transformation, that is key. That's where that energy is lost. And then they're going to continue to the bottom or up to the stairs, so to complete the circuit and start it again. So in doing this, this is the one from the textbook. So this is the one that grade 9 students get all the time. So if you're looking here, I want you to think about this one on your own. Where is the energy the greatest? Where is it the lowest? What is your control, meaning what is your switch? And what is the load? So the load is where you transform the energy. So look at this one and think about it, and then we'll go over this one later. Okay. See you guys in a bit.